Titration looks easy. Fill your burette, pipette your solution, add in the indicator, and just let it flow. Let it flow, let it flow, until you reach your endpoint. So simple, right? Then explain why are all these things appearing on Reddit. Like this Redditor said, 8 years ago, I could never exactly pinpoint where my endpoint is and when I should stop the titration. While another one straight up gave up on life. He could hardly control the burette. And the worst of the worst that I heard in my years of tutoring, the very first video that got me viral on TikTok. Some complained that their endpoints were different color for all his titration. Sorry. And maybe it's true, titration can be challenging, especially for the combined science students. Just ask the students from 2022. Yes! Because knowing how to do titration on paper versus actually using the instrument and the apparatus could lead you down a very different path, especially when it comes to judgment and your and the real problem, how many times do you actually get to practice? You can buy a burette, you can buy a pipette, but how are you going to get the acid? And most importantly, how do you set it up before the police come and catch you?
Oh my god.
And so, I built it instead. The only ChemLab simulator in the entire world, just for you. So that you can practice over and over again when nothing will be unpredictable for your O-level or your A-level chemistry practical. You ready? Let's go! Welcome back to another ChemLab simulator. And today we are going to do the experiment that most A-level students will have to perform during the practical exam. And yes, for chemistry students in the O-levels, even the combined science students, this has proven to come out for your exams before, so better pay attention. Now this is all the stages that you are going to get upon signing up for the ChemLab simulator. $39.90 as a beta tester, you get 15 stages with 12 unique experiments and 3 real brilliant papers from NJC, EJC and Hwa Chong. And all of them offer something different. They are all very unique. But we'll get to that in a later episode. Today, we are going to do the most common experiment, the ones that almost all chemistry students will have to know, your titration. I've already cleared a tutorial, so I am not going to go through that. In fact, I'm going to be a tutorial teacher and we are going straight into the exam mode. And I'm going to orientate you as to how to play the game. So, let's get started. So, exam mode, and this is what you see. Again, WASD is to move around like Counter-Strike. And the basic control, press tab, you're going to record all your results over here. And then press M, this is your lab manual. So unlike your prelim stages, all the individual modulars before the last 3 stages, when you press M, generally you get a lab manual like this, where they'll guide you on what to do, and then you just perform accordingly. So you can see everything is provided here, apparatus, and then there's a procedure. Now, because of time consideration, I did not make the game such that you have to wash in order to get the most accurate titer value. And therefore, when you do this game, when you do multiple titration, you can just assume that it's clean ready. You don't have to dispose of it, even though you can by carrying it to the sink and doing the interaction. So just take it as everything is clean and we can start. So step 1, voided. You don't need to do that. Step 2. This is using the pipette to transfer exactly 25 cm³ of hydrochloric acid into a clean conical flask. So this is the interaction that's rather interesting. So if you look at my table, for the combined science students, you may not have gotten to use this, but again, if you watched the earlier part of the video, that year's titration was something like this, where everything was done for them, and all they had to do was literally just to turn on the tap. For this part, I'm going to teach you how to use the pipette. You take the balloon, which is number 6, you take the pipette, and then you start looking for your FA2 on the table. Okay, so you realize if I point at the NaOH, nothing happens, but if I prompt my HCl, you can aspirate. Okay, because of the graphics, because I want students to be aware that it's already inside, I tinted it yellow. But as you know, in your real lab, hydrochloric acid, NaOH, colorless. Now it's in the pipette, I'm going to put it into a conical flask. You can see it says dispense. Goes in, colorless again, as expected. And every titration is not just about pipette. The complement to it is the burette. So I'm now going to fill up the burette. Again, don't need to wash. So I'm going to look for my NaOH. Now this is my wash bottle. Where is my NaOH? Over here. So you can see, I fill it up. You can see the meter over here goes from 50 to 0. And that's what you see in your burette as well. At the very top marking is 0, and then it goes all the way down to 50, so that you know that the marking that you see is the exact volume that's being added. And if you like, you can move around, you can see, okay, behind that's showing that solution is being filled in. Now remember what I said about science in the previous episode. It's about eye power, it's about observation. But the problem with titration is, most of the solutions are colorless, and therefore in titration, most of the time, you need an indicator to show you that color change. In this context, we have it right here, and that's your indicator. If I'm not wrong, this is stream metal orange. Yes, it's the metal orange. You can press number 3. So let me press away the cursor, press number 3. Now you can add it in. And the indicator is in, it's red. Okay, so a couple of mechanics before I move on. You can press F to zoom in, and this is how you swirl the thing. Just like a real experiment, you're supposed to bring your eye down to see the color change, because the moment the color change occurs, that's where your endpoint is. So what's going to happen is, I'm going to show you how you turn on the burette and then swirl at the same time. So press F again, it zooms out. Now I'm going to on the burette just a bit first to show you. So you can see the volume is going kind of fast, like in real life, but very often, titration needs to be very precise, and therefore you need a dropwise mechanism. This is something that I just patched. How do you achieve dropwise mechanism? You're gonna hold shift and you press E. You hear that? The dropwise? Now again, you need to be swirling, so I'm gonna go down first, I swirl. I can also add and swirl, so I'm gonna press E. You can see a stream going in and swirl, or stream going in and swirl at the same time. If not, you can hold shift E. Because it's going so slow, you don't see the droplets, but you can hear it. Okay, so zoom out. You can see so far I've added 14.55. So I'm going to continue. So I'm going to add a bulk amount first, because I suspect usually titration is about 20 plus. I'm going to try. Okay, at 20 plus, I'm going to start to do dropwise. So press F, zoom in. Okay, this is going to go a bit slow. Waiting for that color change. I really don't have the answer. I'm just like swirling and hoping for the best. Now every drop is adding 0.05 cm cube, just like a real burette reading. Okay, I can zoom out, check, it's about 21. So maybe it's about 23. Let me add a bit more first. Okay, now I'm gonna add dropwise again. So I'm gonna zoom in. So this is gonna take a while. I suspect it's like 25, 26. I can't remember what I included as the answer already. Oh, you can see it's starting to change. So this is the most accurate one. I think it's 24.94. Because the endpoint, if you read very carefully, press M, titrate endpoint is the first permanent color change from red to orange or yellow. You don't want to overshot it. It matters. So this is going to be my orange endpoint. And now this is the interesting part. I'm going to record. So I can just click record, everything goes in. Now, just like your real life experiment, I'm sure some of you may have overshot, but you can kind of feel that where your true title value is. So you may want to adjust your results according to your judgment. How do you do that? You can press a minus, then one of the things disappears, and now you can adjust. So let's say you started the titration from 10, then this will be what you get. The volume added, okay, even calculated for you, because this is a tutorial stage. But once you get to the prelim stages, it's not like this. So I'm gonna change it back again to 0. Oops. So this part, I'm gonna change it back to 0.00. Now, in case you didn't know, your titration is always 2 decimal place. This is it as well. So right now, I think I'm done for the first one. This is my rough. So usually rough is kind of like to let you get a feel of where the endpoint is. So I got it. Now I know. I probably want to add a bulk amount of my annual age, and then towards like 23, then I start doing dropwise to get a better result. Just like in a real titration, you can choose to reuse this, and maybe you can increase the volume to a nice number first. So maybe 24.99. Okay, to me it's good enough. So my starting point is going to be like 24.99, but based on my endpoint, it's like 25, right? Let's take a risk here and see what happens. I have a secret to share with you. For the past 2 months, I've been working hard day and night on this game, and this game is catered to the H2 chemistry students. We all know your A-levels is a highly competitive exam. It is a high-stake exam that will affect your future in terms of determining where you go from here, whether it's NUS, NTU, SMU, or even, like my former student, Oxford. And for every component of your A-level exam, most of the time, it's about repetition, it's about the amount of effort that you put in, it's about the amount of time that you dedicated. However, one component is clearly not the same, and that component could be the biggest differentiator in terms of separating you from the B students, and that is the H2 chemistry paper for the practical exam. Because unlike every other component where you can do the papers at home, the practical component is about practicing your experiment skills, knowing exactly what to do, even though you could be shaking for your life. And in schools, you're limited in terms of how often you visit the lab, how often you get to practice the experiment, and sometimes it's just doing it once and you move on. And therefore, I have a solution. For you and my students, I have developed multiple stages of individual experiments before developing the prelim exam. Meaning, in this prelim exam module, all the experiments will be laid out for you. You will be tasked to do all 3 experiments before answering the questions, all while having the same real interaction and failure that you would experience in a real lab scenario. And that means you see color change, you see precipitate, you even see effervescence. This is as real as it can get, and nobody else out there is doing this. So if you're passionate about getting the A for your A-level H2 chemistry, and you want to be able to work on the component where most of your friends do not have access to, such that by the exam you'll be very confident walking into the hall, knowing that you probably secured about 100% of your practical component in your H2 chemistry exam, so that you have the highest chance of scoring an A for your actual A-levels. Wait no more. Sign up today and you get a lifetime subscription to the game. Now, back to the video. So I'm going to show you how to reset the experiment, how to continue a titration from where you are. You're going to take the flask, press number 8, go to the sink, you dispose, you put it back. Again, you assume that everything is dry, you assume that everything is clean already. And this is because of time consideration. A lot of things here you may not use right now. This is for later part where there's dilution factor. But right now we're just focusing on the basic part of the titration. I'm going to again do my pipette. I can read my lab manual again, press M. So, rinse, use the pipette, add to 2 to 3 drops, and you titrate again. So now we're at this part. Repeat to obtain concordant titer values. I took this from my actual exam paper, so don't come at me for my English. Then after that you gotta calculate, but that's another thing. So, pipette, number 6, then number 5. Sorry, number 6, then number 5. Always 6, then 5. The balloon, then the pipette. Look for thing to aspirate, HCl, put it in. So for now, I already experienced. I'm gonna put in my indicator. Turns red. Okay, again, realize that your endpoint is where it first turns orange or yellow. So this is like 24.99 already. You can choose to top up, but for this one, I choose not to top up. I show you that it can still go on. So I'm gonna keep adding right now. I'm gonna swirl. Okay, so I think we are almost there. So just to write in, record first, 24.99. My endpoint is not yet, so I just put it like this. Later I can adjust. So I'm gonna add Dropwise. So zoom in, Dropwise. Oh, you can see it's turning orange, just like that. So I'm gonna zoom out. So I can write this part, 49.96. So the result's about 24.97, which is what you expected. Now this part of the game, because I didn't patch the volume very well, meaning you can still see 24.94, 93, but in the future stages, the later stages, especially the prelim papers, they are all going according to your Burette, which is that it measures up to 0.05 cm3. And you can see, this is rather consistent. This is the results. They even calculated the mean titer value for you. So, gonna show you what if you want to top up or you want to reset as if like you want to do everything from scratch. You're gonna take the flask, wash, Burette, you're gonna fill up all the way to the top. So you look for your NaOH. I'm looking on the left, NaOH. Just press E. Hear the sound effect, and it becomes 0.00. So 655 like that. Then you're gonna aspirate your NaOH. So which is here. Oh, I swear I did not prepare this. So I just accidentally did the wrong order. It's supposed to be NaOH inside HCl that's being pipetted. I really did not plan this. So you can see the interaction allows you for failure. And this is amazing practice for your O-levels or your A-levels practical. Because in real life, we don't actually guide you on how to do it and you're allowed to make mistakes. I can confidently say all the stages that I planned, I've allowed room for error and I want you guys to make the error. A lot of the experiments that I've put in there is such that there's flexibility in terms of error or in terms of how you can do the experiment to achieve the same ideal results or even a better procedure to get the better results. Everything is coded for. So just for completion's sake, I'm gonna try. You see, I can put it NaOH. Okay, but if you know chemistry well enough, you know that the Titre value wouldn't change, but it allows for it. And you can see the color change. Remember just now was red. Now it's yellow. So you can see the total reversal. And in the real experiment, you're supposed to realize, wait a minute, this is totally different from my lab manual. You can see over here, it's supposed to go from red to yellow. But right now I got yellow. That means if I continue titrating, I'm supposed to get red. And we're going to put that to the test. Put my game, the ChemLab simulator, to the test. So again, the Titre value should not change. For students who have done titration many times, you will know why. So I'm gonna switch it on. Start swirling. By the way, swirling is important. I accounted for that, I'm telling you right now. Oh, okay, so 24.5. So the volume is a bit fast. The later stages are already coded for that. I already adjusted for how fast the volume will get added in. So I'm gonna zoom in, I'm gonna do Dropwise. You can hear the Dropwise. Swirl. It's supposed to turn red because it reversed the whole thing. Didn't turn red. So I guess I didn't code for that. Let me try. Let's try a bit further. Let's go faster, see whether it changes to red at all. Whoa, so I guess I didn't code for that. I thought I did. I guess I did it halfway then went to sleep. So I guess this will be my next patch notes that I'm gonna fix, but you can see, the main thing is that the moment you try to do something wrong, the game does reflect that. And if you choose to ignore that, ideally you should still get the same results. I'm pretty sure the rest of the stages, especially the prelim stages, I coded for the fact that if you make a mistake, you can still continue and it will show you the wrong results that will make sense in terms of chemistry. But in this case, because it's the earlier stages, like I said, the earlier stages are the ones that are a bit rough. And you can see right here, even though I coded for it to be yellow, but I didn't code for it to turn red at the endpoint. Supposedly consistent with the chemistry. So yeah, guess that didn't work out. I guess that will be in the next patch notes. So the last part here is we need to submit our results. I'm gonna click submit, and this is the important part. You don't want to continue experimenting, you want to see your results. You can see everything is written down here. Even the calculation in terms of how to do it, if you read the question and they're giving you the marks for it. I got about 2 out of 3 because my Titre values are not concordant, whatever that means. I missed by a bit. So that's all for the titration part of my ChemLab simulator. So let's say you want to try again, just click the green one. You can try again. Let's say you want to move on from here to the next stages. This one I didn't code for it, haven't patched for it yet, which is that the button is actually over here, top left. Click, you're back at the main screen. So you can either redo it, you're back at 0, or you can go on to other stages. Things like that. I hope you enjoyed this one. I've showcased to you how titration works and how my game is able to provide you a realistic scenario of what is going to happen in the lab in terms of the correct answer, in terms of also the wrong answer. Close enough. So if you'd like to see more of this, let me know in the comments and subscribe to me. Nothing else. This is Yao from Vantage Tutor, a class above the rest. Take care. Oh, titration came out. Oh, you didn't expect it? Hi, this is Yao from Vantage Tutor, a class above the rest. Now today I've been reading Reddit and Reddit is going off. Mainly they're talking about how the combined science students were not expecting titration to come out for their chemistry practical exam. Well, honestly, I'm as surprised as you are when I read through Reddit because of my years of teaching combined science students. I do realize that titration for chemistry has not come out for practical, and this is the first time. Has this happened to my students and I before, where you get something that you don't expect? Yes, specifically for my H2 chemistry students in 2019. I recall I was preparing them for the planning question and we came across this package that I prepared. Is this planning on organic chem? Yeah, I mean, I did see a question like this in the package. We should probably try it. But my teacher said organic chem won't come out. And I never tried it before. Yeah, you're right. We probably shouldn't waste our time on this. Yeah, let's skip this. And lo and behold, what came out for planning? Organic chem. Now obviously I'm not trying to ask you to either spot questions or not prepare for anything, right? What I'm trying to say is this. There are indeed questions that will not come out. There are also indeed questions that are not taught to you in a very explicit way, but it's actually in your syllabus. To be fair, today's experiment was a bit unfair to the combined students because from what I know, none of the combined science students has even tried a burette or pipette before. So all of them just fumble with all the equipment. However, at the same time, if you talk about context of A-level chemistry syllabus, your practical exam generally shouldn't come out electrolysis or organic synthesis. Number one, electrolysis, even myself, I've done it less than 2 times and it was with a computer. I had an electrode connected to a computer to analyze all the results. As for organic synthesis, I took about 24 hours, basically 4 consecutive lab sessions to actually synthesize an ester of less than 5% yield. So for my A-level students who are worried about unforeseen circumstances such as like getting you to do electrolysis and organic chem whatever, I think it's very unlikely. And as I told all my students, platinum is worth a shitload of money. Steal the platinum electrode and run.